Alright, so last night I was fiddling around with trying to get a decent approximation of things like e and pi and cube root of pi, square root of pi, pi on 4, square root of pi on 4, all this sort of stuff, right? These like values that are not supposed to be constructible. And I was looking for ways to do it with origami. So here's what I was doing as I was working through it. And where's the one that I'm going to show you? Pi on 4, this one. Approximating pi on 4 via root 2. Yeah, it's going to be this one. So this a is up here. 1, let's see. 1 minus root 2 on 2. That's what the value of a is. Anyway, so here. In Desmos, I've plotted off a rectangle that is the size of a regular sheet of US letter paper, 8.5 inches by 11 inches. So this would be the 11 inches, this is the 8.5. And what we're going to do is we're going to treat one short edge as the y-axis, and we're going to fold it in half so that we get the x-axis. Okay, fold it in half long ways, right? So this is your x-axis, this is your y-axis, and this is the value we're shooting for. Okay. This height here is 1. This height here is 1. This is 0, so this is down here, this is -1. Up here, this is +1. That doesn't matter as much because you can flip it, it's symmetrical, so it doesn't really matter. But that's how we're treating it, okay? So out here, this is, if we folded this edge down to this line, this corner would be right here. And that fold looks like this. And then we're going to want to do that just for the sake of reasonable precision. We're going to do that on the other side too. So here we folded this corner to this point and this corner to this point. And now we can get that line across from edge to edge where those folds meet. This line is now x equals 1. Okay. And now what we're going to do is we're going to fold this line to the x-axis. So we'll get this. Okay. And now while we're here, this line, this point here, has now come down to the x-axis. So we can now fold. We can mark this. This is the square root of 2 from 0. This is the square root of 2. Alright. And now from here, we want to go from here where it contacts down to here. So what we're going to get is we're going to get a value over here somewhere, which is 1 plus half of the square root of 2. Right? So here's 1. Here's the square root of 2 again. And what we want to do is we want to cut that in half, so it's going to be right in this ballpark here. Right, so where this line, this fold, passes through the x-axis, that is 1 plus half of the square root of 2. This is square root of 2. Alright? Now, just for visual reference, there it is. There's that line, 1 plus root 2 on 2. We actually don't need to drop this line in. That's just for reference. What we need is this point. That's really all we need. Okay. Now, what we're going to do is we're going to fold this edge over here to this line. So what we're doing is we are cutting this in half. Right there. And then we're going to fold this edge to this line. So we're going to cut that space in half. And we're going to repeat folding from here to here. And let's see, one more time. Because what we want to do is we want to create, we're looking for 15ths. the easiest way to do that is to go for 16ths and then back off 1. So if I fold this distance in half, I get half of it. If I fold that in half, now I'm looking at quarters, then eighths, now 16ths. And now what I'm going to do is I'm going to go from, I want to divide this space by, I want to multiply it by 8/15. I want to multiply this distance by 8/15. So this is 0, this is 15, this is 0, this is 15. So what I'm going to do is I'm going to fold a line from here through this point and look at where it intersects here. Okay, so this is the point that I'm interested in. And now what I want to do in order to get 8/15, I want to fold a line from this point through here. So that's what this guy does. And the equation of that line is insanity, but when you're just doing origami, it's real easy. And now, so recall, this is what we're going for. This point right here is a really good approximation of pi on 2. So if we fold this edge, this point, to this point, we cut it in half, and we get pi on 4, very, very accurately. Boom. And there it is. That point right there, if this is 1, this distance from here to here is 1, this distance from here to here is extraordinarily accurately pi on 4. It's not exact, but if you're actually using a piece of paper that is 8.5 by 11 inches, the difference between the actual value and what you just constructed, even if you did it perfectly, which is pretty much impossible, even if you did all of this exactly perfectly, the distance between those two values is within the width of the crease because of the thickness of the paper. So I can zoom in here and you can see how accurate this is. There, it's just now starting to show up. So there's actual pi on 4. There's our crease. Even at this scale, you can't see the difference. So if you had a sheet of paper that was like a meter across, you might begin to be able to tell the difference between the value we constructed and pi on 4. So for practical purposes, especially within origami where you're working with sheets of paper that are normal sized, this should work very, very well.